In this lecture, I will be presenting an overview of the organization of climate data on the ECRI Data Warehouse, as well as how to access those data. Okay, so then the next question is, what climate data do we actually have available on the data warehouse, on this website? So off to the right, this is just a depiction of precipitation projections across a wide variety of different climate model forecasts or projections in the Volta River Basin. The observed line is black, and all of the colored lines represent different climate change signals, with the dark lines being the ensemble means. So the first set of runs that we have available come from the CMIP3 run. That is the set of model runs that come out of the fourth assessment work produced in 2004. We have a total of 56 runs at a monthly and daily resolution. Now, you might remember the emission scenarios we described earlier in the SRES set of scenarios. It's 22A1B, 17B1, and 17A2. And those are the intermediate emissions, the low emissions, and the high emissions scenarios, respectively. So a total of 56 runs available at both of those different time steps, and all of these are available at a half-degree resolution for the African continent. The next is CMIP5 runs that are actually using a spatial disaggregation technique, meaning this is this simple inverse distance weighting approach. The first is monthly data, and we have 43 runs of those available. That's 23 of the representative concentration pathway 4.5 and 20 of the RCP 8.5 runs. So a total of 43 runs available on a monthly time step. And in this case, because of our availability to actually download all of these data, we only have 17 of the daily runs available. So that's 9 of the RCP 4.5s and 8 of the RCP 8.5s. Lastly, using this more sophisticated downscaling technique developed by the University of Cape Town, empirical statistical downscaling is what it's called specifically, for both monthly and daily time steps, we have available 22 runs. This is a total of 11 of the RCP 4.5s and 11 of the 8.5s. Lastly, I'll describe how to access the data and some of the key characteristics of the data that you'll need to understand in order to work with it. So first relates to access and downloading of the data from the data warehouse page. Now, a link is provided to an FTP site on the main page in the data warehouse. That site can be accessed through either Windows Explorer or through any number of FTP management software, such as FileZilla, which is free. In Windows Explorer, as an example, simply take the FTP site and paste it into the address bar, and then that brings you to a window from which you can simply drag and drop files onto your desktop or onto a folder on your computer. It's very straightforward. In FileZilla, it's actually even more straightforward in some ways, because that program will set up a sequencing approach where you can batch up files and let them run overnight. Now note that there are hundreds of gigabytes of data, of climate data, and if you're interested in downloading most of it, it will take some time, especially if you have a slower internet connection, so it will be important to use something that allows you to batch if that's what you're interested in trying to do. So how are these data organized, and what are some of their characteristics? The folder and file naming structure is organized by CMIP3 and CMIP5, which is the 2007 and 2013 IPCC archived outputs. Emission scenario, and that's going to be 5 different scenarios, so RCP 4.5 and 8.5, and SRES A1B, A2, and B1. GCM names, and there, for example, with RCP 4.5, there are 23 monthly GCM outputs, so 23 separate files for that RCP alone, and then also temporal resolution, so monthly and daily. This is the folder and file structure. All of these data are in MATLAB format. MATLAB is the original engineering software package that was used to process these data and work with these data. That is still the format that the data remain in now. There are 121 monthly projections and 95 daily climate projections total, and these span the period 2001 to 2050. There's also a daily and monthly Princeton historical data set between 1950 and 1999. which is available, and that can be used for comparison between these projections into the future and what actually occurred historically over Africa. The spatial dimension is the 10,639 grids that are each half degree by half degree, and this covers all of the African continental land areas, including Madagascar. A key is provided that includes a grid centroid latitude and longitude for each of those 10,639 grids, so that you can use GIS or another software to actually map these data into a two-dimensional space and look at them and look at changes and things of that nature. Okay, so this ends this particular presentation. To summarize, we've provided a background on the climate models available through the data warehouse and how to access these and work with these through the FTP site. Thank you very much for your attention.